Hi friends, let's study for the semester 2 final for Math 8. In this final we are going over modules 4 through 8 and we are going to do this together. All right, I've already, just so you guys know, making a little cheat sheet for myself. I've already done all this. There's a couple of things that are a little bit of an issue on here. So before we get into really solving things, go to the very last page. The height of this cylinder is 20 centimeters. I've written that in your work for this day. And then for this advanced proficient, legit, just ignore it. There are so many problems with this problem. Can't even go into it. I need to rework that entire thing. All right, here we go. So I'm on page 1. This is our statistics and probability unit where we were looking at line of best fit, data sets, and that sort of thing. So we have a scatter plot that shows the test scores of students based on their time studying and looking at this data here. We need to write an equation for this linear model using 2 points on the line and label our variable. First point that you should always use if you have it is your y-intercept, and our y-intercept is 0, 60. Use it. It is literally a gift from the mathematical gods. The other one that I am going to use is this data point right here because it's clearly on or very close to the line. And so this data point is 490. Now you could use other points along this line. You could say, I'm going to use this point or I'm going to use this point, whatever, cool. This one's legit like on the line. Just find ways to make your life simple. So find points that are on the line to make your life simple. So I'm using these 2 points. If you use different points, you could have. Good luck. I'm not going over your particular answer on here. I'm going over mine. So pay attention to the process. You'll do the same. So first thing, I need to find the distance between these points vertically and horizontally. I'm finding the slope. The slope formula, m is equal to y2 minus y1 over x2 minus x1. So using this, we're going to use these points. I'm going to say this is point number 1. This is point number 2. Totally arbitrary. Again, it does not matter if you say this is point 1 or this is point 2. It does not matter. I always go from left to right to make my life easier, and I go from there. y2 is the y value of the second point, 90, minus y1, y value of my first point, minus 60, over x2, 4, minus 0, x1. So now I have 30 over 4, which I can simplify to 7.5, so it makes more sense in the context of the problem. Essentially, it's saying that the score rises 7.5 percentage points for every hour studied, which is kind of sweet. As well, I can see this is my y-intercept, so I can create the equation y is equal to 7.5x plus 60. If you want to, you could also write this in fraction form for this number. So you could write 15 over 2, because I'm going to simplify that, times x plus 60. Should always write my fractions in simplified form, right? Yay. All right, so now using the scatter plot above, what is a reasonable prediction for the number of hours studied if you got a 75% on the test? I'm using this line and I'm using the information here to try to find that information. So 75% on the test is right here. I am going to drag this over till it meets the line, and then I'm going to go down to the value on the x-axis that corresponds to. So I'd say 2 hours. Look at all the math work that I had to show. I literally drew a horizontal and a vertical line. Like, not hard. Show the work. Next, what is a reasonable prediction for the test score if someone spends 5 hours studying? Excuse me. 5 hours studying. Right here, 5 hours. I'm going to take this up to my line. Not quite 100%. So I'd say bring it over to the side over here. It's pretty high up there. So I'd say probably between 96 to 99 hours, or percent. So that means I would probably say like 98-ish%, which I think is what is given in the answer key. So just be aware, 98-ish% would be reasonable. Excuse me. All right, next problem. Given the ice cream sales versus temperature graph there, create an accurate equation that describes the line of best fit using your equation and explain what the slope and y-intercept mean in the context of the problem. Remember, this is an advanced proficient problem. You do not have to do it. I'm not expecting you to do it. If you choose to do it, you accept the consequences that it's hard, okay? So looking at this, I am creating an equation for this. You can create whatever equation you want, given that it needs to end up like sort of filling in with this line. Looking at this, I don't have a y-intercept given to me. If I look at this data, it goes to 10 here. So it's not even 0, which is intense hard. Okay, so I'm gonna look at this point here where it crosses this 12, and I'm gonna say it's about 12,200 right there. And I'm gonna find another nice point along this line. And if I look at this right here, it crosses nicely with grid lines, and I'm gonna say that point right there is 22,500. Again, you can use lots of different points here. It just needs to be reasonable for the graph that you're looking at. And these 2 points are fairly reasonable for this graph that I'm looking at. I need to use the slope formula to find the slope of these 2 data points. So I'm going to say 500 minus 200 divided by 22 minus 12. Again, I use this as my data point number 1, and this is my data point number 2. y2 minus y1 over x2 minus x1. When I do that, I get 300 over 10, which simplifies to 30. So that 30 is representing how much I'm going up and over to get to these different data points. The meaning of that slope is $30 in sales. It's essentially we're increasing these ice cream sales, $30 in sales for every 1 degree in temperature increase. Where do I get that information? From this right here, my labels here. I am increasing by $30 for every degree value. So for every $30 in sales for every 1 degree increase. The meaning of my y-intercept, I don't even know it yet, so let's find it. I have this base equation, y equals mx plus b. I have a slope of 30 that I already know, and I have 2 points that I'm basing this off of. I'm going to use this lower of the 2 points because it's less math work. It's slightly easier numbers. I have an x value of 12 and a y value of 200. Now notice, that's not a y-intercept, it's a y value. So I'm putting where the y is and the x is. This is a point that this problem goes through. So I have 200 is equal to 30 times 120 is 360 plus b. I'm going to subtract 360 from both sides. So I get a b value of negative 160. So I can write my equation y equals 30x minus 160 now. Now I have to explain what that y-intercept means. I have negative 160 as my y-intercept. What does that mean? Well, that when the temp is 0 degrees Celsius, there are negative $160 in sales, which means they probably aren't making any money, and instead they are paying more for employees, and overhead. So that's like electricity, insurance, all that sort of stuff. They are paying more for employees and overhead than making a profit. Big explanation for that question, but the biggest idea is that when the temperature is 0, there's negative $160 in sales, meaning they're not making any money. They're losing money when it's that cold. In other words, that's why ice cream shops in Montana are not often open, or at least they don't expect lots of sales when that sort of thing is happening. And it's that cold. 0 degrees Celsius is 32 degrees, and in Montana that's quite common, so maybe we sell a little bit more ice cream than somebody else, but think Florida. Okay, all right, next, Graph the systems of equations below and find the solution. So in here, this is module 5. What we were just working on before was module 4. Now this is module 5. Module 5 is all about systems of equations. With these systems of equations, we are graphing, we are solving by elimination, and we are solving with substitution. Here we go. Here's our first one. Y equals 2x plus 5. I'm going to graph this. We're graphing the system of equations and finding the solution. This, my y-intercept is 5. My slope is 2, so I'm going up 2 over 1, which takes me off the graph. So I can also go down 2, left 1, down 2, left 1, which is the same positive slope. Down 2, left 1, down 2, left 1, down 2, left 1. So please do not forget what our dear old friend Slope Dude says. Positive 2, that's a puff, puff, positive slope. Puff, puff, positive line. Make sure all of that is connected. This one, I have a nice negative slope, negative. So Slope Dude would say nice negative. It's also got a y-intercept of 0. It's not there. So I'm going to have 0, 0 as my y-intercept and a slope of negative 1 over 2. Negative 1 over 2. Down 1 to the right 2. Down 1 to the right 2. And I'm going to bring it backwards. Ooh, I found my intersection, and I'm going to create this line. My intersection point, it's at negative 2, 1. X value of negative 2, Y value of 1. Negative 2, 1. That's where those two lines cross. Next question. 2 students are reading a novel. Ashley reads 10 pages per day. Carly reads 8 pages per day, but she started early when was on page 40. Write a system of equations to represent this situation. So first equation is Ashley's. Y equals 10x. Ashley reads 10 pages per day. The other equation that we're going to create is for Carly. Every single sentence in this is going to create a new equation. Carly reads 8 pages per day, and she starts early as on page 40. Cool. Those are our 2 situations. Our x value in here means days read, and our y value is pages. That's the number of pages that they are reading. So now we need to graph this system of equations. For Ashley, she starts at 0, 0, and she reads 10 pages per day. And notice our x values are not based on 1, 2, 3, 4 days. It's based on 5s, which is kind of annoying. So I'm going to put 10 into my equation. 10 times 10 would be 100. So in 10 days, she'd read 100 pages. As well, if I put 20 into there, 10 times 20, that gets me 200 pages. 200 pages. And I have now this line for Ashley. I'm going to do Carly's in black. She's starting at 40 pages, and I'm going to do the same thing for her. I'm going to put values in. If I put 10 into this equation, 10 times 8 is 80 plus 40 is 120. There's a point. And if I put 20 in there, 8 times 20 is, what is that? 160 plus 40 is 200. So there's our intersection point. So here is Carly's line. Now this intersection point, we have 20, 200. What does the point of intersection on the graph tell us about Ashley and Carly? At day 20, Ashley and Carly, I spelled Ashley wrong without an E. Ashley and Carly read 200 pages each. They're putting the same point in their book, 200 pages in. This next problem, solve the system of equations below and write your answer as an ordered pair. So we're going to solve this system of equations. We can do it lots of different ways. Looking at this problem, I see that these x values are easily multiplied. I can multiply this bottom equation by 3, or these y values are opposite of each other and easily multiplied. So I can multiply this top equation by 2 and get an elimination sort of situation, which is what I'm going to do. Substitution is not the best choice in this case because I don't have any variables all by themselves, which means substitution is going to be hard. Okay, so I'm going to multiply this top equation by 2. So I get 30x minus 8y equals 1 24. The reason why I multiplied this top equation by 2 is because I like to add things together. If I had -8 and a +8, that would add to get me 0, which I like. That means I have less complicated math work, and in my brain, that really, really helps. So if I add these two equations together, the y values will disappear. -8y plus 8y, 0y. And I can do that addition all the way through. I have 35x plus 0y is equal to 210. So I'm going to solve this equation. Divide by 35 on both sides, so I get x is equal to 7. With this information, I'm not done. I need to find an x and y. Notice every single one of these, I found an x value and a y value, x value and a y value. I have an x value of 7. I need to find the corresponding y value. I'm going to put it in this second equation because it's less complicated. So 5 times 7 plus 8y equals 86. And I'm going to solve it. So I have 35 plus 8y equals 86. Subtract 35. Wow, what did I do wrong? I did something wrong. No, I didn't. I did something wrong on my other. Oh no, this is equal to 7. Or this is equal to 6. Math is wrong. Sorry. That's equal to 6. I was like, I should get 6 there. So I have 6 here. Let's do this in black. 6. So 30 minus 30 from both sides. And now from there, the math will be a lot more understandable. I get 56. Divide by 8. Divide by 8. I get y is equal to 7. There's my 7. So I have 6, 7 for my point here. Apologies for my math error. I hope that didn't screw you up too bad. So there is that proficient problem. This next one, write and solve a system of equations using substitution, which is a slightly more complex task. For how many hours of labor will it cost to fix a car for both of these different garages? We have Motorworks and Jim's Car Care. So looking at Motorworks, we have $650 for the part and 670 hours of labor. So it means y equals 70x plus 650. For Jim's Car Care, we have the same situation here. We have $55 an hour for labor and $800 for the part. It's got an expensive part there, plus $800 for the part. So those are our two equations. We're going to solve this using substitution. In other words, we are going to take one equation and set it equal to the other equation. So I'm going to say 70x plus 650 is equal to 55x plus 800. And I'm solving that math. I don't really have a lot of space. I should have done that differently. So I'm going to subtract 55 to start out with. So I have 15x plus 650 is equal to 800. Now I have better movement, minus 650 on both sides. More space. I have 15x is equal to 150. That means if I divide by 15, x is equal to 10. What does that 10 mean? X in this case, when we did 70x plus 650, x is equal to hours of labor. That means whatever I get for a y is the total cost. So this is 10 hours. Now I need to figure out the total cost in that amount of time. I'm going to do this top equation because 70 times 10 is nice to do. So I have 70 times 10 plus 650. I'm going to do that math work. So I have 700 plus 650, and I total get 1350. So that's the cost of labor for 10 hours of work at both shops will be the same amount. 10 hours of labor is $1,350, $1,350. Cool? You'd have to do all of that math work to be able to get that advanced proficient. Next one. This is more of our statistics module, so this is more of module 4. We're looking at two-way tables. So if you're going back in your book and you're looking at this stuff, I believe this is lessons 4.4 and 4.5. So for this, a total of 76 students responded to a survey about transportation to school. One of the girls surveyed, 22 walk to school and 29 get a ride. Of the 25 boys surveyed, 9 get a ride to school. Construct a two-way frequency table to display the data. All we have here are totals. Different things that we're looking at is we are looking at girls versus boys being surveyed. And then we have people who ride to school or get a ride to school or walk. They total said that we have 76 total students who responded to the survey. So I'm going to put that there. Then it gives us little hints along the way. Of the girls surveyed, 22 walk to school and 29 get a ride. So that's nice. I got girls. I can do that math and I can say I have 51 total girls. Boys, of the 25 boys surveyed, 25 total boys, 9 get a ride to school. So 4 boys, of 25 of them, 9 get a ride to school. That means 16 walk to school. Now we can do some math work on the side to find the totals of how many people get a ride to school and how many people walk to school. So 29 plus 9 is 38. And then 22 plus 16 is 38 again. So we're all done. We created the two-way table. This next one, Jane polled 50 students about their preferred after-school sport and then recorded the data in the two-way table to the right. Create a two-way relative frequency table. Relative frequency table. That means we're looking at percentages relative to the grade level. And it says relative to the grade level. That means the grade level column is going to be 100%. So I'm treating all of these like they are the totals. So I'm going to look at soccer for 7th graders and say 21 or 11 divided by 21 to get a percentage. 10 divided by 21 to get a percentage for baseball and vice versa. So as I do this, I'm going to make sure, I believe your test has you doing this to the 10th place on the practice test when you enter this in. So that's what I'm going to do here. 11 divided by 21. Excuse me, I get 52.4% for soccer. For baseball, 10 divided by 21, and I get the same sort of thing, 47.6%. And I'm finding just those percentages each time. 27 divided by 29, 27 divided by 29, and I get 93.1%. I could do this math. I could say 100 minus 93.1 and get a value out of that, and I get 6.9%. And I can check my work if I wanted to do. I say 2 divided by 21 and get that percentage. Oops. Wow, what did I do wrong? 27 divided by 29. I think I did the wrong math there. No, 93.1. And then 2 divided by 29. I did the wrong thing here, I think. 6.89, so 6.9%. Sorry, 38 divided by 50. We can do that. And you should get 76%. And we could subtract these two to get 24%. You're all done. You filled it out. Nice work. Next, advanced proficient. Create a two-way frequency table given the following data and determine the likelihood of the following statement by finding a relative frequency, or finding the relative frequencies is really what we need to do for this one. So we have a little bit of information here. And if we look at this, it says on-time homework and after-school jobs. So kids are on time with their homework and they have an after-school job. There's 8 of them. On time for homework and no after-school job, don't have a job. On-time homework, 25. So we have 33 total people that have on-time homework. Often later missing homework or after-school job. Late homework, have after-school job, 12 of them. Often later missing homework, no after-school job, 15. So this isn't an overly difficult frequency table to create, but the question afterwards is definitely more complex. So I can finish creating that frequency table. And now this, students with after-school jobs are less likely to have on-time homework than students without after-school jobs. So looking at this, I need to contemplate what information am I really looking at? Students with after-school jobs, students who have after-school jobs are less likely to have on-time homework. on-time homework than students without after-school jobs. So I'm looking at this 8 divided by 20 information and creating a frequency there, and then comparing that to people who don't have a job and how often they turn in their homework. And so we have 25 divided by 40, and looking at those two relative frequencies. 8 divided by 20, that creates a relative frequency of 40%. And 25 divided by 40 creates a relative frequency of 62%. So what I would say here is this is a true statement because people with after-school jobs turn in homework 40% of the time on time versus 62.5% if they didn't have a job. So relative frequencies do not lie. They kind of help us out in that case, which we probably could figure out from the raw data as well. But at the same time, it's helpful to see those numbers and really be able to make solid thoughts from that. Next problems. I'm going to pause for a hot second. Sorry. All right, unpause. I'm back. For these next problems, we have to do a little bit of work. I'm going to use my patty paper to help me out. You're going to be able to use patty paper on the test, so I highly encourage you to continue to do that. For this particular problem, it's a little tricky. Let me see if I can zoom in a little bit. For this particular problem, what is a sequence of transformations that maps figure PQMN to figure RSTU? Be specific and pay attention to corresponding angles. That pay attention to corresponding angles bit is super duper important, especially for this problem. So this is, if you're looking at this, this is from lessons 6.1 through 6.5 in our workbook. Looking at this, I have P and R. Notice where they are. These are corresponding angles. As well, check this out. This also helps. Q and S are corresponding angles. So do you see that? We're not necessarily rotating this shape. Looking at this information, that tells you that we're probably looking at a reflection. So looking at this, I am going to create my shape on here so I can play around with these different bits. I'm going to say P, N, M, and Q. I have them written down. And so now I'm going to play around with some movements. There's lots of different movements that you can make to make these work, but the most efficient mode would probably be to do a reflection and then a translation. So looking at this, I'm going to reflect over the line that P goes through. That line is X values equaling 4. Okay, this vertical line is the X value equaling 4. Do you see 4? X equaling 4. That's a line. Okay, so if I reflect it over that line, I end up with a shape that looks like this. I have PQ. I have this shape now. N, M, Q. From there, I need to translate it down and move it over to the right. So the movements that I would be making, and I can see that right here. So translate it down and over to the right. Boom, I'm there. I've got it all lined up. So the moves that I just made, and again, you could do lots of different moves. I am going to quite literally have this patty paper, probably this exact one, and I'm going to move it around on your thing and I'd be able to say whether or not it's correct. Actually, I won't use that exact one because that's not the same problem on your test. But either way, that's essentially what I will be doing. I'll be moving a piece of patty paper around and saying whether or not you're right. So first things first, I'm going to write all this information down. I am going to reflect P, Q, M, N over line X equals 4. Notice all the information. For reflections, I need the line of reflection. For rotation, I would need the direction of rotation and the degree. For a translation, and the center of rotation. And for a translation, I need to know the how much I'm moving down or up, how much I'm moving left to right. So I've reflected, and now after that, I need to figure out how much I'm translating down and how much I'm translating to the right. Then translate down. Let's see how many units. From here, I'm going down 1, 2, 3, 4, 5, 6, 7 units. Down 7 units. From there, I'm translating over 1, 2, 3 units. And left direction, 3 units. So I have all that information there. You would need to have all that information as well for you. This next problem over here, we have is ABC similar to angle EFD? That means all of our corresponding angles would be equal. So we have 18 and 110 and 18 and 52 here. So we don't have all the information, but we can see that A and E, we're off to a good start. A and E are corresponding angles, and they're also the same angle measure. So we can say 18 plus 110 and do the math work there, and we get 128. And we know all triangles add up to 180 degrees. So to find this missing angle, we're going to say 180 minus 128 gets us 52 degrees. So this is 52. C is the third angle here, corresponds to D. They're both 52. So yes, we can say triangle ABC is similar to triangle EFD because corresponding angles, you can use shorthand, so corresponding angles are congruent. Yay! I'm going to zoom out again. See if I can do this nicely. Here we go. The next one, a dilation maps point Q right here to its image Q prime 2, 4. Complete the dilation of figure QRST and label the image Q prime, R prime, S prime, T prime. What is the scale factor? So if we're looking at just the points 1, 2 to become 2, 4, we can see that each one of these points is being multiplied by 2. So our scale factor is 2. So we can start off right there with that. Now I'm going to zoom in so we can see this figure and how it gets bigger. So Q is at 1, 2. Q prime is at 2, 4. So I'm saying 2, 4. And I'm going to label that Q prime, 2, 4. Each of these points is going to do the same thing. They're all going to multiply by 2 in terms of their values. So T is at 3, 2. If I'm going to multiply 3, 2 by 2, that means I get 6, 4. 6, 4 is my T prime value. I can do the same thing with R. R is at 3, 4. So that is 6, 8 is my new 6. 8 is my new R prime value. S is at 5, 5, so double that is 10. 10 is S prime. So now we can make all of these points and connect the dots, and we have this new shape. If we wanted to, you could see if you're right by essentially drawing those straight lines from 0, 0, from our center of dilation to there. And how do I know 0, 0 is our center of dilation? It's not explicitly stated here, but you can see the values are increasing. And if it wasn't through 0, 0, we wouldn't have these straight lines. So if we could just connect these lines together, all of them would travel through 0, 0. So if anything, if it had another question there, I could say, what is the center of dilation and the scale factor? The scale factor is 2, and our center of dilation is 0, 0 because they all go through 0, 0. Cool? Cool. Zoom back out. Next problems. All right. The height of a shed is 6 meters. Ooh, we're looking at Pythagorean theorem, guys. So this is module 7. A ladder leans against a shed with its base of 4.5 meters away and the top just reaching the roof. What is the height of the ladder? So if we're going to put this in perspective, we have like a little lawn here. We have a nice little shed here. cool little shed, and it reaches, this ladder reaches its roof, okay? So the height of this roof, the height of the shed and its roof is 6 meters, and the base is 4.5 meters, okay? So we're using the Pythagorean theorem. We want to find our hypotenuse, leg. So we're going to say 6 squared plus 4.5 squared equals c squared. We're going to do this math. We get 36 plus, I don't remember my math here, is plus 20.25 is equal to c squared. We're going to add these together, so we get 56.25 is equal to c squared, and we can take the square root of both of these. So just c is equal to a nice number, which never happens, of 7.5 meters. So this ladder is 7.5 meters long. I'm going to box my answer so I can see it. This next problem here was actually a problem on a test, so you might see something similar to this on your final, so just be aware. Zoe draws LMN on the coordinate plane. So the question that we had on our test is similar. We had to find the perimeter of this, but we can also find the area. What is the approximate perimeter and area of LMN to the nearest hundredth? Show your work. So looking at this problem here, we have a few things. This side length here is 12 units long. And then we don't know what these two side lengths are. But what we do know is those two side lengths are on nice points, which we can turn into a right triangle. Look at that. I have a right triangle here. Isn't that cool? So we have 3 units by 6 units here. And technically this is also 3 units by 6 units here. So we can do the Pythagorean theorem on this to find our c values, our hypotenuses of each of these, because when we're finding the perimeter, we're finding the entire distance around. So we can say 3 squared plus 6 squared equals c squared. So 9 plus 36 is equal to c squared. 45, if we do that addition, and take the square root. So when we take the square root, we get approximately 6.71 is our c value. We have 2 of those. Both of them are the same. So we're going to say 6.711 times 2, because we have 2 of them, plus 12 is going to be our perimeter. Let's put this on the screen. So our perimeter is all of that added up, which is 25.7 or 442 units. Now the area aspect of this is definitely a lot easier because area for a triangle is 1/2 the base times its height. And our base of this is 12 and our height of this is based off of a 90-degree angle with the base, which is 3. So in this case, the area of the base and the height is really not hard to find, but don't be surprised if you have a funky right triangle or an isosceles triangle or an acute triangle or all sorts of different things for that where you might have to do more complicated math. But 12 or 1/2 times 12 times 3 or 6 times 3, which is 18 units squared is my area. That's my area. Cool? Cool. Now this next problem here, do the following side lengths create a right triangle, why or why not? And we have 8, 11, and 15. We are going to take this side right here and we're going to say that is our hypotenuse. Why? Because it's the longest one. So 8 squared and 11 squared are our legs. Our longest side is our hypotenuse. We're going to do this math work. 8 squared plus 11 squared equals 15 squared. So we get 64 plus 121 is equal to 225. And if we add these two together, 64 plus 121, I get 185 here. And that is supposed to equal 225, but does it? Nope. This is not a true statement. So that's essentially using the converse of the Pythagorean theorem. This would be an answer of no, because the Pythagorean theorem is false. with these side lengths. All done. Done. It's false with those side lengths. Next question. Two right triangles have side lengths of square root of 24 and 6. What could the remaining side lengths be to make two right angles? Or what right triangles? So again, advanced proficient problem. You don't have to do it, but if you want to, I encourage you to, or whatever you feel, okay? Square root of 24, I'm gonna start there, and I wanna find out what that equals. Why? Because I wanna see if it is bigger than 6 or less than 6. Square root of 24 is approximately 4.9, and then we have 6. Which one's bigger? 6 is bigger, so I could pretend that's the hypotenuse of a triangle, and I could say the square root of 24 plus b is equal to 6. We could have all of these squared, okay? Or I could use this as the square root of 24 squared plus 6 squared equals c squared, essentially using them both as legs and solving for a hypotenuse. We're looking at these two scenarios. Square root of 24 squared is 24. Don't have to do any tricky math work there. Is equal to b squared equals 36, or plus b squared equals 36. Could subtract 24 from both sides. So I get b squared is equal to 12. I can take the square root of both sides, and when I take the square root of 12, I get an approximate side length of 3.46 units. That's one potential side length. Another one, 24 plus 36 is equal to c squared. So we get 60 is equal to c squared. Take the square root of both sides. Square root of 60 is 7.75-ish units. And that is equal to our other side length. So if we treated these two sides as if they were legs, we could have a hypotenuse of 7.75 units. And if we treated 6 as if it was a hypotenuse and square root of 24 as a leg, we could get our other leg as 3.46 units. So those are our two options there. Next page, last one. We're almost done. Guys, you're almost done. And your video so far is like running about 9 minutes faster than my algebra one. So this is great. And again, we get to ignore this advanced proficient problem. Now there will be an advanced proficient problem available to you on the final that does make actual sense. This one just doesn't. So apologies for that. Ignore it. Here we go. We're going to start here. A cone is shown below. Find the volume of the cone if the diameter is 8.5 inches. Use 3.14 for pi. Round to the nearest hundredth. So our diameter is 8.5 inches. That means the radius, this is the diameter, the radius is 4.25 inches. Our volume of a cone equation is 1/3 pi r squared times height. So we're going to use all of this information to answer this problem. Volume of a cone equals 1/3 times 3.14 times 4.25 squared times 15. We're going to do this math. And if we put all of that in a calculator, we get the volume of our cone to be 283.58 inches cubed. Look at that label, inches cubed. The next one, surface area of a cone. This is more complicated. We have the same information. Our radius is still 4.25, but when it comes to surface area of a cone, we need a bit more information. So surface area of a cone equation is pi r squared plus pi times radius times slant height. So we need to find our slant height, which means we need to find we need to use a Pythagorean theorem. So we're going to use the Pythagorean theorem. We have one leg and another leg, and we're finding our c. We're finding our hypotenuse. So we're going to say 4.25 squared plus 15 squared is equal to c squared. We're going to do all of that math work, and we get, when we do this math, we get 243.0625 is equal to c squared. If we take the square root of both sides, we get our C, or our slant height, to be 15.59 inches. So that is our slant height. So now we're going to use the surface area equation with our slant height to find the actual surface area of the cone. So surface area is equal to 3.14 times 4.25 squared plus 3.14 times 4.25 times our slant height of 15.59. When we do all that, we get a surface area of 264.76 inches squared. Woohoo. Next one, sphere. Use the sphere below. What is the volume of a sphere? Use 3.14 for pi and round your answer to the nearest inch. Volume of a sphere equation is 4/3 pi r cubed. So 4/3 times 3.14. This time we're given our radius of 3 cubed. And when we do all that, we get 113.04 feet cubed. Done. What is the approximate volume of this cylinder? Use 3.14 for pi and round to the nearest hundredth. Remember, I'm saying that the height is equal to 20 meters or centimeters here. Apologies for my lack of label on our practice test. So we have volume of a cylinder is pi radius squared times height. We're going to do this work. We have 3.14 for pi. Our radius, we have a diameter, so that means our radius is equal to 5 centimeters. And our height is 20 centimeters. So when we do this work, we have 3.14 times 25 times 20, and we get 1,570 centimeters cubed for our volume of our cylinder. Again, we get to skip that one. So hopefully this helps you figure out what you're going to put on your cheat sheet. You should definitely have things like slope formula. You should have things like how to find the y-intercept. You should have ways to find percentages because you have that there. You will want to have stuff written down in terms of what you need for being able to describe a reflection or a translation or a rotation properly. And little things like the Pythagorean theorem and converse of the Pythagorean theorem. Maybe have examples of them. And then every single one of our insane equations that we need for volume. Don't forget circumference and making sure you are aware of that you might have to use the Pythagorean theorem on problems. All right. Thanks for watching and good luck on your test on Monday. I'll see you soon. Bye.